All right, here we're going to do an example of finding the force required to keep this 100-pound crate from sliding down the ramp. And we assume that it's like ice on there, there's no friction. And so the question is, how much force does someone got to push on that so it doesn't slide down? And the angle here is 30 degrees. All right, so what we do here is, this is a classical, this is really important. Students, of all the applications, this is a one type that's important because it comes up in physics and engineering, these basic types of problems. So what we want to do here is, we know the force of gravity pulls straight down, and that's 100 pounds, so gravity is pulling down 100 pounds. So the magnitude of that vector is 100. Now if we draw perpendicular to the incline here, then this is, let's call the force F. This is the force F. This is a 90-degree angle here. So this is the force we're going to have to push on there. This is parallel to this, and it gives us the force. Now it turns out from geometry, we know that this angle is the same as this angle. So right in here, this is 30 degrees. Now I like to give students kind of a visual. Hopefully it'll show up on this video here. But why does it work like that? Well, let's consider something like this. Here's a book, okay? And we got this. Hopefully that's showing up, this string here. And then let me take this little piece of paper and keep it perpendicular to the book. As the book moves, we get an angle between right here. We get this angle here, and it moves and moves. As I move this angle here, right here, that angle is the same as the angle right here, created between right here and here. So this angle, which is this right here, is the same as the angle right here, because as we move this, let me get this thing to stop swinging. When we move this, we see it just, they're the same thing. So it kind of gives a nice visual of to go beyond just geometry. It gives a nice visual to show why that's true. All right, so now to solve this, well, it's pretty simple once we understand how to set this up. Well, we know sine is opposite over hypotenuse. This is the 90 degree. So we know the sine of 30 is F over 100. Therefore, our force is 100 times the sine of 30. The sine of 30, 30, 60, 90 triangle, we have 1, 2, square root of 3. So the sine of 30 is a half. So the force needed is 100 times a half, or 50 pounds. So someone would need to exert 50 pounds of pressure this way. If this 100 pound was on a block of ice, basically no friction, and we had a 30-degree angle, that's how much you would have to push to keep that still. A little more than 50 pounds, it would push that way. A little less than 50 pounds, and it would come down this way. Yeah.